Hey guys, so today we're at the Bridgeport boss, and our job for today is we need to make a socket. Um, since I'm working on this Bridgeport, what I'd like to do is I'd like to change the bearings in the end caps for the X and the Y, and in this instance we're actually here at the Y. Sorry, I'm a little handheld here. Try to bring you in, zoom you in a little bit. So we need to make a socket for this, so I can pull this front shaft out and cover off and get the actual ball bearings out that support this Y-axis shaft, and then we're going to go ahead and replace the bearings. But for now, we just need to do this. We need to make this socket first. So that's the scope. And let me bring you over to the lathe, and we'll start turning some metal. Okay guys, before we get started, I just want to let you know what material I'm going to use. I ordered a piece of 1144 carbon steel. Should provide a nice finish. It's pretty easy turning, and I got this from McMaster-Carr. It's a 2-inch piece. Our outside diameters and dimensions are not super critical. The only thing that's really going to be critical is the tooth spacing and the tooth placement to engage in that that nut that's on the Bridgeport. Okay, so we flipped apart. We're going to go ahead and just clean it off, face it, throw a chamfer on it. I may just clean this up a little bit, and I might just leave it a little bit proud. It's a socket, so we're not looking for any kind of particular specs on it, just whatever we feel like doing it. We will have to bore out the center to 777 thousandths, because that's what the shaft on the Bridgeport is, and we have to have clearance for that. So that's what we're going to do now, and I'll make the cuts, and we'll go from there. Okay guys, so we got it to the proper inside diameter. We're at let's see. I already measured this, but apparently the camera wasn't on. Let's clear it. And we're at 775, which is fine. So now we're going to go ahead and pull it off the lathe, and we're going to set it up on our Bridgeport because now we have to make the slots to form the socket. Hey guys, we're at the Bridgeport. We have the socket on the super spacer, and we have the coaxial indicator in the quill. So now at this point, I pretty much have it dialed in, but I'll just go around so you can have a look-see. I'm pretty much close enough. Good to maybe I don't know, half a thousandth. So now we're going to get the, we also have the DRO zeroed out, so now we're going to get the tool bit in there, going to do the math, and we're going to make the cuts to make our socket. So what I've done was I went to the Bridgeport, and I took my gauge block set, and I went ahead and that's how I calculated the width of what I need to, or that's how I calculated the width of the pins. So it's a 4-pin socket. So there's just going to be 4. We're going to cut, you know, just about 90% and just leave 4 pins or 4 teeth sticking up at 90 degrees. And the super spacer, I put a 4, I guess a 4 position plate. Let's see if I can go down and show you that. So all I needed to do was unlock it, spin it, unlock it, spin it, just do that, and we should be able to, it's at 90 degrees each section of the rotation. So we're going to be good to go. So let's get that together. We'll get the bit, we'll calculate the math, and we'll start to cut. Okay guys, so we got the mill set up. Now what I did was I raised the knee up just about close to touching it. I put a shim here. I'm just going to drop the quill down until it touches the shim. I'm going to lock the quill. Let's see what the thickness of the shim is. Shim is 15 thousandths. It's actually, goes for my vise, but matter of fact, let me close the vise up real fast so all the chips don't fall in the lead screw there. It's the only thing that I don't like about these Kurt vices. Okay, good. Excuse me. Now what I did was I measured the teeth of the socket, and I grabbed a stack of gauge blocks, and the gauge blocks that I needed were 160 thousandths. That was their total. And I'm using a coated cutter. It's a 1/2 inch 4-flute end mill, and I'm going to go to a depth of 750 thousandths or 3/4 of an inch. So I'm going to go ahead and adjust the knee readout to 0. I'm going to use the scale on the knee. This is a socket. We don't need to get super crazy. And the DRO is zeroed. So, and the table is locked. So what we want to do is we want to take the Y and unlock the Y. And if our teeth are 160 thousandths wide and our cutter's 500 thousandths round, so we want to take half of that, 250 plus, of course we want to add 80 thousandths for the tooth, because that's half of the tooth. So we're going to move our y-axis 330 thousandths and see if we have clearance in the back, because obviously we don't want to cut the tooth behind. So let's go ahead and move this back 300. $330 thousandths. Okay, so our DRO is now 330 thousandths. Looks like we have clearance behind it. So let's go ahead and take some cuts and see how she works. Now we have the Y locked. We're going to unlock the X. I guess we'll bring the table up. Let's try 20 thousandths and see how she goes. Okay guys, we got the first half of the tooth done. We're gonna go, we went 200 thousandths deep. So I think that's deep enough to engage the keys on the mill. So what I'm gonna do is I'm gonna lower the Z 200 thousandths that I came up. And I'm going to unlock the table and rotate it 90 degrees. Now we're going to cut our next portion of the keyway. Now theoretically, if we were to go all the way across, that should be our slot. It should be perfect either way. So let's go ahead and lower the knee back down. And let's take a 20,000th cut. And we're going to feed over to the right now. And let's see if it works. It looks quite a bit wider than 160,000, so maybe that's not the way to go. Yeah. Alright, so let's do it the other way. Let's go ahead and 0 the X, just so we're in the middle. Not that that matters. And let's bring the Y to -328 instead of positive. Let's go ahead and lock it. Seems like we're right in the same spot as we were before. Let's take a cut here and see. Alright guys, so didn't make any mathematical errors, but what had happened was the flutes weren't the same size as the shank, and I just expected that to be a 1/2 inch end mill. So I recalculated, I reset the DRL, I relocked the table, I made a test cut, and I see that my tooth that I did the full cut on was 160 thousandths on the money. So we're just going to go ahead and cut the rest of the teeth and everything should be great. All the shimmy sham should be fantastic. triple sure, I'm going to check each tooth. Perfect. Perfect. Okay. Excellent. One more tooth to go. Okay. 161. Reflections on the job. I think I could have been well suited to have bought a new end mill. I think this end mill was kind of shitty. Now that the teeth are cut, I need to remove these pieces here. And how will I do that? I can't lock this in halfway. Or can? Oh, yes, I can. Alright, so I'm going to lock this in between and just take off these little tidbits over here that are left over. And we should be done. Okay, we'll pull the part off and deburr it and see what we got. Quarter edge of that tooth there with the cutter, but it is what it is. We're done.